Can you work with a mesh model? If you've heard this phrase before from a customer, you probably know what comes next. Instead of a clean, NURBS solid, you'll be looking at a part comprised of thousands of triangles imported from a file type such as STL or 3MF, and data that might have numerous holes or other imperfections that immediately present challenges to overcome before you can work with it. Thanks in part to the proliferation of low-cost 3D printing and scanning hardware, the use of mesh models has exploded in popularity over the last few years. Traditionally, working with meshes or scanned mesh data has required specialized software tools to clean up the geometry enough to make it useful in a CAD/CAM environment. Mastercam 3D HST and multi-axis toolpaths have supported mesh entities long before Mastercam 2022. But cleaning up mesh data and zeroing in on just what you want to cut has been a challenge. Mastercam 2022 launches with a full suite of mesh editing tools to tackle the increasingly prevalent use of meshes in manufacturing. Let's step through the process of importing a mesh model and exploring some initial view and preparation tools. Here we have a suspension arm for a bicycle. This is a part that could be cast and then see some focused finish machining to produce the final pivot bores and clean up the swooping arm surfaces and pockets for aesthetic purposes. This is actually a very clean mesh, but it's still come in as one giant model and not as a collection of individually usable surfaces that we can quickly leverage for our toolpaths. The orientation of the model also isn't square to any existing plane, so we'll have to address that as well. Just like any other entity, we can adjust the mesh color in the Attributes group or in the right-click menu. If we turn on Section View on this mesh and then also toggle Backside Coloration on, we can see if the mesh surface has the correct vector orientation. Mesh surface normals are editable in the same way as surfaces in case these weren't facing the correct direction. If we analyze this mesh with the F4 key, we can see the polygon count and the volume. Taking a closer look at the bores and the lightning pockets in the side of the suspension arm, we can see that we have these black sharp-edged lines, even though the model is still only one big entity with no defined areas. This is a visual helper in the shading options of the Appearance group. Edge angle tolerance is currently 28, meaning that any angle difference between mesh edges greater than 28 degrees will receive this heavy edge line treatment to denote a sharp surface change. If we up this number to a large value like 90 degrees, we can see the part display change in the graphics window as we exclude display of areas that don't have this specified sharp angle transition. This edge display gives us a good visual representation of the changes in mesh topology. If we also wanted to view the individual polygons that make up this mesh, we could turn on Show Triangle Edges. This will be an important view option when we get into other mesh tools and heavy editing, but for now, we'll leave this off. Let's get this part squared up before we begin setting up toolpaths. I'll launch Bounding Box and turn on the Auto Orientation option. Going into the advanced options, I'll turn on Create Tool Plane and name it Arm Plane. Since I know this should be a symmetrical part, the Auto Bounding Box will quickly give me a coordinate system that is square to the pivot bores and along the center line of the arm. The next thing I want to look at is how to split this model up into areas that I can easily select for machining, since having the entire arm as one entity isn't helpful for toolpathing. For this, we'll launch the Explode Mesh command. This will take a single mesh input and separate it into individual mesh patches depending on the user filters. Flatness is used to determine the degree to which mesh areas are allowed to deviate while still being considered an individual region. Noisy or dirty mesh models might require a high flatness value to ensure that surfaces that are close to planar are still retained as their own region and not split up along the roughness peaks. Edge angle tolerance is a degree value that is used to determine when to break a mesh into separate regions. An 80-degree angle tolerance, for example, would only split a mesh into different regions if we saw a transition between facets that was very close to a square corner. Merge percentage determines where we want to combine adjacent regions that are technically separate according to our flatness and edge angle rules, but are producing sliver regions that bloat the total mesh count unnecessarily. Let's set a flatness of 3.5, an edge angle tolerance of 25, and leave merge percentage alone. Explode Mesh has now recognized 33 different regions of this model and has colored each one individually. We can see here that it did a great job of separating the lightning pockets and bores from the main body of the arm. From here, we can launch right into creating finishing operations like equal scallop in these pockets. Curve All Edges now also recognizes the region extents of each mesh body, so we can also now set up some dynamic operations to cut our bores. We've only just scratched the surface of mesh manipulation in Mastercam 2022, so stay tuned for more videos on how to use all of the new mesh tools to take your modeling to the next level.